Alrighty, so continuing with 3.5, we have our examples. And make sure you do these, please. Don't skip over them. This is a little more difficult than you think it is. Maybe not. Alright, using roster form and set builder notation, how do you write T is the set of natural numbers that are less than 6 in roster form and in set builder notation? So roster form is just when you list them out, right? So you're going to say T equals 1, 2, 3, 4, 5. Again, all natural numbers less than 6. Set builder notation, T, right, is the set X such that X is a natural number where X is less than 6. That's it, set builder notation. So on here, N is the set of even natural numbers that are less than or equal to 12. How do you write N in roster form and in set builder notation? So roster form is listing them. 2, so here we have N equals, right, 2, 4, 6, 8, 10, 12. So again, even naturals, less than or equal to 12. That is roster form. Set builder notation, you're going to have N equals X such that X is an even natural number and X is less than or equal to 12. Something to that effect, right? So inequalities and set builder notation, this is where it gets fun. In set builder notation, how do you write the solution of this? So obviously you want to solve it first, right? So subtract the 7, right? Divide off the -5. Remember, when you divide off that negative, you flip the inequality sign, and X is greater than or equal to -2. So in set builder notation, X such that X is greater than or equal to -2. That's it. Again, X such that, let me make that bigger, X such that X is greater than or equal to -2. Solution of this one in set builder notation, obviously starting out by subtracting your 9, -4n, again, don't lose that negative, greater than 12. Now we're going to divide off that -4. When I do that, I flip the inequality. N is less than -3. And again, set builder notation, N such that N is less than -3. Alrighty, so we mentioned the vocab subsets. What are all the subsets of the set 3, 4, 5? Don't forget the null set is a subset. That's a quiz question, by the way. You can list them separately, 3, 4, 5. Those are each individual one-element sets. You can list 2 at a time, 3, 4, 3, 5, 4, 5. And by the way, 5, 4 is the same as 4, 5. Likewise, 5, 3 is the same as 3, 5, right? And then list all 3. So the entire universe, 3, 4, 5, is also a subset of the universe. So there are 8. 1, 2, 3, 4, 5, 6, 7, 8 subsets. Alrighty, so got it here. What are the subsets of P equals A, B? So we'll start out with subsets of P. You're going to obviously list the null set first. Just don't forget it. You're going to list the whole universe, A, B. And then you're going to list A by itself and B by itself. And so there's 4 there. And by the way, another way to write the null set is also just empty brackets, or empty braces rather. That's always acceptable. Okay, so the other one, subsets of A, B, C, obviously the null set. Then there's the whole universe, A, B, C. Then each individually, A, B, C, and then we have the 2 elements. It's AB, BC, and AC. So there we have it. Count them up, right? And then reasoning. Hang on a second. Let A, so the set A is X such that X is less than -3, and B, X such that X is less than or equal to 0. Is A subset of B? And explain your reasoning. Okay, so here's the idea. If you look at a number line, by the way, my B, so set B is going to start at 0, and it's going to be everything to the left, right? And including 0, don't forget that. And my set A is going to start at negative 3, open, and goes on to the left forever. Notice that A overlaps B completely. So yes, every element of A is in B, since negative 3 others less than 0. So A is definitely a subset of B. If even one element had been different, you could not count it, by the way. So to brief the review here, when working with sets, you call the largest set you're using the universal set, or the universe. The complement of a set is the set of all elements in the universe that are not in the set. Again, A and A prime, right? Complement of A is A prime. Venn diagram kind of shows the idea. A is shaded, so A is a subset of the universe, right? And then if my whole universe, right, is here, the complement of A is everything that's outside of A that's still inside of the universe. Some folks like the visual there. So finding the complement of a set. Story problems, right? Universal set, king, queen, bishop, knight, rook, pawn. And set A is the set of chess pieces that move side to side. What is the complement of A? So the king can move side to side, so can the queen. So can, does the knight? Knight moves up and over, and up and down, that sort of thing. Rook is side to side, pawn is definitely not. So we're saying that king, queen, and rook are the ones that move side to side. Yes, I guess the knight's sort of up and over or down and over, depending on how you look at it. So it's definitely not a side-to-side thing. But neither is the bishop, and certainly not the pawn. So the Venn diagram again shows a relationship between the universe and the complements. So the complement of A is bishop, knight, pawn, the ones that are not the side-to-side movers. Alrighty, so your universe this time is months of the year, and set A is months with exactly 31 days. What is the complement of A? Write the answer in roster form. So here you have the months of the year, so January, February, March, April, May, June, July, August, September, October, November, December. And I've written and circled the ones that begin with, I have 31 days. So again, universal sets, all 12. Set A is exactly 31 days. What is the complement of set A? So the complement of A, so A prime, is going to be, and it wants these in roster form, complement of A is going to be February, April, June, September, November. And there you go. February, April, June, September, November. The complement, the ones that don't have 31 days.